This video is on solving equations with variables on both sides. To solve an equation with variables on both sides of the equal sign, you want to add or subtract to get the terms that contain the variable on one side of the equal sign and the terms that do not contain the variable, that is the numbers, on the other side. Let's take a look at several examples here. So we need to solve each equation and then check our solution. Here we have 5x plus 2 equals 6 minus 7x. You'll notice that I have a term with x and a term without an x to the left of the equal sign, and the same thing over here on the right of the equal sign. So I'm going to move, I kind of like to have my x's on the left. So I'm going to move this term here, this 7x, but actually I'm going to think of it as a negative 7x, and I'm going to add 7x to both sides. So 5x plus 7x is 12x plus 2 is equal to 6, and this negative 7x plus 7x creates a 0. Now I have 12x plus 2 equals 6, so I'm going to subtract 2. So now I have 12x, and that makes a 0, is equal to 4. Now getting x by itself, x is being multiplied by 12, so I want to divide by 12. So x is equal to 4 over 12, which simplifies to 1/3. Now, let's check our solution. Oh, this one's not going to be fun. That's okay, we can do it. So 5 times, putting in 1/3 for x, okay, plus 2, don't freak out, we can do this, equals 6 minus 7 times 1/3. Okay, so 5 times 1/3 is 5/3 plus 2 is that equal to 6 minus 7/3. Now remember that when we're checking our solution, we're just doing PEMDAS on each side of the equal sign. So I can't subtract 2 or I can't subtract 6 on each side. Would be nice, it would make this a little bit easier, but I can't do that. So I need to write 2. Remember, I need to have a common denominator. So 2 over 1, I need to write that with a denominator of 3. So multiplying top and bottom by 3, that's going to give me 6. So 5 over 3 plus 2, written as 6 over 3, is that equal to, now I need to do the same thing with 6. 6 over 1, I need to write that as something over 3. Okay, so I multiplied by 3, so I need to multiply this by 3. That makes sense. 6 is 18 over 3. So I'm going to write 6 as 18 over 3 minus 7 over 3. Now I can add and subtract my fractions. 5/3 plus 6/3 is 11/3. 18/3 minus 7/3 is 11/3, and good, it does check. So my solution is x equals 1/3. Okay. Next example, oh look, we get more fractions. Okay, so we have 1/3 times the quantity 18 plus 12x equals 6 times the quantity 2x minus 7. Let's go ahead and distribute. So 1/3 times 18, it's the same as 1/3, let's do it over here. 1/3 times 18 over 1, don't be afraid of that. It's the same as 18 over 3, which is equal to 6. So 1/3 times 18 is 6. You can also think of it as 1/3 of 18. 1/3 of 18 is 6. Plus, we need to do it again. 1/3 of 12 is going to be the same as 1/3 times 12 over 1, which equals 12 over 3, which is 4x. Don't be afraid to do a little extra work over on the side if it helps you to understand better. Okay, here's the distributing is going to be a little bit easier. 6 times 2x is 12x. 6 times negative 7 is negative 42. Okay. As I said, I like to keep my x's to the left of the equal sign. You can put them on the right, there's no problem with that, but I'm going to go ahead and move this x over here since it's positive. I need to subtract it. So I'm going to have 6 minus 8x, because 4x minus 12x is negative 8x, equals, that makes a 0, negative 42. Now subtract 6, because that's a positive 6, subtract 6 on both sides. Don't lose track of that negative in front of the 8x, is equal to negative 48, and then dividing both sides by negative 8, I have that x equals 6. Okay, so let's go ahead and check this. So 1/3 times 18 plus 12 times 6. Is that equal to 6 times 2 times 6 minus 7? Okay, 1/3 of 18 plus 12 times 6 is 72. Is that equal to 6 times 12 minus 7? This is 1/3 of 90. 1/3 times 90. Is that equal to 6 times 5? Well, 1/3 of 90 is 30. 6 times 5 is 30. So this checks, and my solution x equals 6 works. Okay, 2 more examples. Stick with me here. All right. This one has 5 times the quantity x minus 5. 8 times the quantity 5x minus 2 is equal to 10 times the quantity 32 plus 4x. Let's distribute. 8 times 5x is 40x. 8 times negative 2 is 16. 10 times 32 is 320. And 10 times 4x is 4x. 40x. Okay, let's get both of our x's on the same side, and I'm going to subtract 40x. And I'm going to subtract 40x. So this makes a 0. So I'm left with 320 over here. This makes a 0. And I'm left with negative 16. Negative 16 is not equal to 320. So the answer to this is no solution. What does that mean? That means that there is no value of x, no number that I can choose out of all the infinite number of numbers that I can plug in for x that's going to make that an true equation, that's going to make each side of the equal sign equal to each other. How else did I know that? Actually, when I got to this step, I could have noticed that my coefficients of x were the same. Here I have 40x minus 16, and here I have a 40x plus a 320. I had a 40x on both sides, but then my other numbers that I were adding were not equal to each other. So there's no way that that equation was going to be solvable. So the answer to that is no solution. And let's take a look at this last one. 4 times the quantity x plus 20 equals 1/5 of the quantity 20x plus 400. So distributing, that's going to give me 4x plus 80 equals 1/5 of 20x is 1/5 of 20, which is 4x, plus 1/5 of 400 is basically 400 divided by 5, which is 80. And I can actually stop right there and take a look at this equation. I have 4x equals 80 equals 4x equals 80. That's true. No matter what value I put in for x, that equation is always going to be true. So my solution for this is all real numbers. That means that x can be anything. No matter what I put in for x, that equation is always going to be true. I don't have to go any further. Notice that my coefficients of x are the same, and that my constants that I'm adding are exactly the same. So in this video, we took a look at how to solve an equation that has variables on both sides of the equal sign. The main way to do that is to get all of your terms with x on one side, all of your terms without x on the other, and then solve it as though it were a multi-step equation.